they wanted to do is they said, draw a right angle. So you measure 90 degrees here, and you draw it. And what do you know? It goes right through the center. So if you have a tangent line, you remember that if you draw a tangent line, and a tangent is when a line touches the circle only once, then if you draw from that point of tangency to the center, it's a good song? Jackson? Is it a good song? It looks like it's a good song.
It looks really good.
That'll always be 90 degrees. So we can fill this out. The tangent to a circle is perpendicular, is the word. And remember, that's 90 degrees to the radius of the circle. Ba-bam, ba-boom, ching. Okay? And this will open up all sorts of abilities to solve questions. So look at this first one. These diagrams are not to scale, but they tell us
What was the other word? It was perpendicular and...
to the radius of the circle. Oh, I like these. These are like little puzzles. So now, they tell us we have the center at O. We have a tangent line at Q. What angles can you figure out?
You could find angle PQO because this is 90, so...
Yes.
48 might be... I don't know.
Those two would have to add up to 90. Does that make sense? So you would figure that one out as 42. Now the question is eventually saying, can you find this angle here? And normally in these questions, if you try to find the answer to the question they're asking right away, directly, you will always get it wrong and you will always guess. Those are both bad choices. Okay?
Oh, this isn't isosceles triangle, so the angles are the same there, so 42 over there.
Oh, nice. Notice you have two radiuses making an isosceles triangle. So these are like little problem solving, like, what do I have? What are the pictures that I have? And we're right here as far as, do you have a pencil today?
Yeah. That was 96 then.
And then that one's 96. Okay? And sometimes in some circle courses, they make what's called a corollary. Whew. How's that for a math word? The word of theorem is something that's always true. One of the theorems that we've learned is that an inscribed angle is what of a central angle? Half. Okay? Not yet. Here, I'll take the originals and put them back in. So we call that a theorem, and sometimes if we know something like an inscribed angle is half of a central angle, notice this one. I'm going to draw on here another point right here. Zoom. Can you tell me what this angle is of this point right in here?
Maybe, yeah, half of it.
48. So I'm just going to call it an interesting property. The angle between a tangent and a chord is always equal Yeah, it's an interesting property. So you notice that the original angle they gave us was 48? That will always be equal to the inscribed angle with that same chord, which is kind of cool. Yes, all of his stuff is on your quiz. So can you see that you could have also solved for this 96 by first drawing an inscribed angle, seeing it's 48, and then doubling it? But I like the isosceles triangle because it was drawn for us already. Sometimes drawing new lines is important. Often you have to draw a radius to solve some questions. But if you draw too much, it gets too busy. But I'm gonna give you some busy ones. It's gonna be fun. Okay. O is the center of this circle. AC is tangent at B. Angle DBC is 37 degrees. So we can go on here. Where do we put the 37? Right here. So we go DBC. This would be the 37. What is the measure of DOB? Okay, same thing. We could use the isosceles triangle again, right? If this is 37, then this will be, to make it add up to 90, 53. And if that's 53, and this is a radius, and this is a radius, making an isosceles triangle, then this is 53. Angles in a triangle always add up to 180. This was the one they wanted us to find. Oh, and I did something in the last question that I shouldn't have. It said, what is the measure of angle POQ? We should actually write POQ equals 96 degrees and circle our answer. Because just because I have it labeled on the picture, that doesn't necessarily tell the teacher that you know which one angle is which. So we should highlight our final answer. And over here, coming back here, 53 plus 53 is 106, has to add up. That makes this 74 question. DBC is this one right here. What's that? Okay. So we can now say that angle DOB is equal to 74 degrees. And can you see that that's just double the 37? Because if the 37 was equal to the inscribed angle, and the central is double the inscribed angle, so now the central angle will always be double the angle between a tangent and a chord. Woo! Okay. Center at O. MN is tangent at M. If MN is 15, okay? Now, I hope you're getting to the point where if they give you lengths and they ask you lengths, your brain goes, I have to use a squared plus b squared equals c squared. I have to look for right-angled triangles if it's possible. So as soon as I got a number here, my brain automatically goes, is there any right-angled triangles? Is there any ones that I can do? So I know that OM is 8. And there's a rule that says tangents to the center are 90, so you're allowed to put that 90 there. What could that let us solve for?
Well, if you don't find all of the hypotenuse.
Right, we can find from O to N. So would you agree that 8 squared and O to N, and you can actually write it like this, O to N squared. (64) plus 225 equals ON squared. 289 equals ON squared. Square root both sides. And you get O to N is equal to 17. What do they want us to find? We want to find this length from here to here.
And then you gotta subtract 8 just to know that, so
Yeah, we've got another radius here. Again, that should be a strategy that you're starting to see in these circles, that if you see one radius, it's like the famous saying, you know one radius, you know them all. I don't know if that's famous. It's probably not. Yeah. So now if I know that this is 8, because the whole thing has to be 17, N to P has to equal 9. That's good tunes. Okay. Center O. Radius 11. Do we have any radiuses? Yes, we have one there. Boom, 11. Tangent at B, another tangent. Oh, this one doesn't tell us it's a tangent, but it tells us 90 degrees in the picture, so then we would know it is a tangent.
Wait, what? Oh, yeah, sure.
Try the box. Try the box. Come on, try it. Try it. They tell us O to C is 29. Oh, how long is this then?
It's 40.
O to C is 29. So can you see that I could also label this as 11? And then this one is 18? And the whole thing is 40. I'm going to draw that like this. Because I knew this was another radius of 11. And they told me that O to C was 29. 29 minus 11 to get 18. And I now know that the whole length is 40. That's important because I have a big right-angled triangle. I want to figure out how long it is from A to C. Oh, they do tell us another thing. I was like, I'm missing something. They tell us that this is 12. And A squared plus B squared equals C squared. I can go 12 squared plus 40 squared equals AC squared. 12 squared is 144. 40 squared is 1600. Add them up and we get 1744, which doesn't work out nicely. That'll be somewhere, that'll be around 43 squared. 43 when you square root it? 40.55? Oh, no. Square root of 1744. Yes. Quiz? Oh, 41.76. Did I say it was around 42? Okay. Again, I look afterwards to make sure, hey, there are units, so I have to put centimeters or lose a half mark. Only 2 more questions and we are done. Oh my. Yeah,
looking at it, it's hard, but then once you figure it out, it's easy.
and that's what you got to do. And if you try to solve what it's asking for directly, if you're not paying attention right now and talking to someone next to you and you're like, what, you will, this test is disastrous. But if, you lost your doubloon. Welcome. If you take it one little step at a time, then you're going to be fine. So, circle with center O. AB is tangent to C. Determine the measure of x if you tried to figure this out right away, you cannot figure it out. However, what do you know? If you have a tangent to the center, this whole thing is 90.
So that'd be 32, and then it's an isosceles triangle, so it's another 32 on the other side. And then you gotta make it 180, so it's 116. And then the other side is 64 because it's a straight.
Wow. Whew. Did she even breathe in between? Okay, did you hear what she said? She said, you can figure out this is 32. That doesn't look like it's fitting in the box. Jackson. Was it easy? Yeah, as soon as it's back in the box, then you can hit the easy button. Okay. So once you figured out this is 32 because it adds up to 90, then you recognize this is an isosceles triangle because it has two radiuses. Isosceles triangle have two sides that are the same and two angles the same. So then you know this is 32 as well. Okay? And then she said, this is a triangle. All the angles in a triangle have to add up to 116, 180. So that makes this 116. And then 116 in a straight line. Do you remember the rule that angles in a straight line also add up to 180? So that makes this 64. Okay? Question, is there a way to figure out the 64 without first figuring out the 116? Yes. How? Sorry, say that again? You add the two 32s to get 64, and that's how we got the 116. But these two added to 64 doesn't necessarily make this one. You have to use a rule. Is there a rule that two angles in an isosceles triangle equal a... Well, because 32 plus 32 is 64.
Yeah, so it's that number times 2. It's the missing number times 2.
Okay, my question is, does anyone know the relationship between this angle and this angle? They share the same endpoints. This is an inscribed angle. This is a central angle. So this one's double. You could have used that as well. So the 32 is an inscribed angle with those two endpoints. The 64, where x is a central angle with those two endpoints. And you have a rule that says a central angle is double an inscribed angle if they share the same points. Okay, I have, well, we're going to finish our notes. We're going to work on the questions from the assignment, and then I'm going to give you 4 practice circles, if I can find them, that are kind of like bigger puzzles. Whew. This one looks crazy to begin with, but again, it's not so bad once you break things down. So we want to figure out what this is, CBF, right here. That's what we want to figure out. We're told we have a center D. AC is tangent at point B. What can we figure out? One step at a time. We know that right here is a 90 degree. Yes.
The other two are... Actually, then you got 70 on the other side.
This is an isosceles triangle, so that makes this 70. Perfect. Then you got 140. You could say this one is 40. Okay?
Wait, why is it...
You could also do 90 degrees on this side, and that's going to help us, right?
Yeah, it's 180.
Because this is 90, this is 90, this is 70. What does that tell me? This is 20. Yes, angles across from each other between two lines are the same. That's 20 as well. I like these questions because it's sort of like you don't know the answer right away, but you just sort of keep going, what do I know? What do I know? What do I know? Hopefully no more than that. And then you figure it out. Okay. That's example number 6. So there's the textbook questions. Tomorrow, you must have all your textbook questions done because tomorrow you are taking your textbooks back to the library. Then you better, do you have it here today? Okay, after class today, bring your textbook back to the library.